everyone. So today we are continuing our statistics unit and we're going to be looking at something called normal CDF. But first let's look at the do now. It says the zeros of a quartic polynomial function h are -1, ±2, and 3. Sketch a graph of y equals h of x on the grid below. So a couple of things. First, you need to know what zeros are. So zeros are where your graph crosses the x-axis. Okay, something important also that they said are what those zeros actually are. When you sketch a graph, you need two things. Whoops, I misspelled graph. And then I just erased everything. All right, to sketch a graph, you need two things. The first thing is you need the zeros. And the second thing is you need the end behavior. I clearly cannot spell today. That's supposed to say behavior. For end behavior, you can have either an even degree or an odd degree. We had a little dance to remember this. So for the even degree, your end behavior is both arrows point up or both arrows point down. For an odd degree, the arrows point in opposite directions, either from down to up or from up to down. This was all dependent on the leading coefficient. But now in our problem, it tells us that we have a quartic polynomial. Quartic means degree 4. And 4 is an even number, so we have an even degree. It doesn't specify anything about our leading coefficients, so either of these end behaviors will be okay. So let's start by drawing a coordinate grid, so x-y axis. Now we know our graph is going to have to touch these points, so let's plot those in. So we have -1, we have +2 and a -2, and then we have a 3. Okay? Now you can choose either end behavior you'd like. I'm going to choose both arrows pointing up. If you want to choose both arrows pointing down, that's fine. Now to finish the sketch, you just have to go through all of the points. There you go. It's just a sketch. It doesn't have to be perfect. Okay, moving on. So in a normal distribution curve, so normal distribution is going to be very important for today as well. The amount of data that falls between one standard deviation is 68%. The amount of data that falls between two standard deviations is 95%. And the amount of data that falls between 3 standard deviations is 99.7%. Now, many questions with normal distribution will ask you to find the amount of data that lies in a specific interval. So, for example, here it says the height of women in the United States are normally distributed, keyword, with a mean of 64, standard deviation of 2.75. The percent of women whose heights are between 64 and 69.5, so between is asking us for an interval, is. Now, sometimes it will work for you to draw out the line and find the standard deviations. However, it's not always going to be exact. You won't always have one standard deviation away or 2 standard deviations away from the mean. It might be 1.5 or 1.25. It doesn't have to be the exact one. So when given a specific interval, we are going to use the calculator because the calculator will help us, and it will help us find the exact percent of data that's within those two, well, within the interval. Okay, so here are the steps. First, you press second, which is right here. Distr, which is distribution, which is right here. And then we go to 2, which is normal CDF. We're going to get to typing everything in there in a moment. Okay, now if you have an older calculator, it might look different than mine. You might have to use commas in this order of your information. And I am going to show you how to do it using Delta Math later. Oops. Okay, so number 1, the heights of women in the United States are normally distributed, key word, with a mean of 64 inches and a standard deviation of 2.75. The percent of women whose heights are between, so this is where our interval is, 64 and 69.5 is. So we use our calculator for this because it's giving us an interval. So how do we know we are using normal CDF? Because it is normally distributed. That's very important. And the question gives us an interval. Reason I'm writing this is because in this lesson, obviously we are going to be using the normal CDF button. However, if you see a question on your own, you need to know when to identify to use this normal CDF button. Okay, so going here, we press second, vars, which will give us distr. Go to normal CDF, press enter. It's going to ask for a lower, an upper, a mean, and a standard deviation. Lower is the lower part of your interval, so the smaller number. Upper is the biggest number of your interval, and then the mean and the standard deviation. So before we type it in, let's identify it here. So the lower part of our interval is 64. The upper part of our interval is 69.5. Our mean is 64. And our standard deviation is 2.75. Okay, let's put that information in the calculator. So 64, clear everything out here. 64, 69.5, 64, and 2.75. Okay, now we go to paste, press enter again, and it gives us a decimal. So it gives us this decimal 0.4772 and so on. And it says that we have to round to the nearest percent, but this isn't in a percent yet. So we can do two things. We can either move the decimal place over 2 spots, or you can multiply by 100. If we move the decimal over 1, 2, this becomes 47.724%. And now it's set to the nearest whole percent. So to the whole percent is to this place here. If we were to round, we would look at the number next to it, which is a 7. Since it is above a 5, this will turn into 48%. So this means that 48% of the data falls between 64 and 69.5. Notice this isn't one of our usual standard deviation percents, so we wouldn't have been able to find it just by using the standard deviation and the mean. That's why we needed the calculator. All right, moving on. The lifespan of a 60-watt light bulb produced by a company is normally distributed, super important, with a mean of 1,450 hours and a standard deviation of 8.5 hours. Okay, if a 60-watt light bulb produced by this company is selected at random, what is the probability that its lifespan will be between, so that's asking for an interval, 1,440 and 1,465 hours. So since it has between, that's how we know we're using normal CDF, because it's giving us an interval and it is normally distributed. So why don't we fill out this information, because we know we're going to need it. The lower, so the smallest part of our interval is 1440. The upper part of our interval is 1465. Our mean is 1450. And our standard deviation is 8.5. I know the question did say what is the probability that it will be between this, but remember, percent is a form of a probability. Probability can be represented as a fraction, a decimal, and a percent. So keep that in mind. That's why we're using normal CDF as opposed to any other procedure. So press second, vars, go to normal CDF. Our lower was 1440, upper was 1465. We had a mean of 1450, and our standard deviation was 8.5. Enter, enter, and this is what we get. So we have 0.841489. Now, this didn't give us a number to round to. It was most likely a multiple choice problem that I kind of just made into a short response. So why don't we round to the nearest hundredth? The nearest hundredth would be right here. We look at the 1. Since the 1 is less than a 5, we'd round 0.84. So again, you can have it written like this. You can change it into a percent, or you can change it into a fraction. Any types of those answers would be correct. All right, moving on. All right, so let's look at number 3. It says that the weight of a bag of pears averages 8 pounds. Now, since it averages 8 pounds, that's telling us the mean. It doesn't say mean, but remember, average is the same thing as mean. It's just another word for it. And then it has a standard deviation of 0.5 pound. The weights of all the bags of pears at the market closely follow a normal distribution. This is super important because it tells us why we can use normal CDF. Determine what percentage of bags to the nearest integer weighed less than 8.25 pounds. Now, we're not given an interval. It doesn't say between these two numbers, but it does give us an upper, and it is kind of giving us a lower one as well. Think about it. We're talking about bags of pears. The lowest a bag of pears can weigh is 0 pounds. That means you have no pears. So here, our interval is actually 0, 8.25. Because anything less than 8.25 is in this interval. We can't go below 0 because we're talking about weight. So let's fill in this information. The lower is 0. The upper is 8.25. The mean is 8. And the standard deviation is 0.5. So let's go to our calculator, go to normal CDF, and type it in. So 0, 8.25, 8, 0.5. Go to paste, press enter, enter, and there we go. So we get 0.69146, so on. Now it does want a percent, so we should change this to a percent. Remember, to change to a percent, you can multiply by 100 or move the decimal place over twice. So 1, 2 spaces. That would turn into 69.146%. But we want it to the nearest integer. Integer is whole number. So it'd be that 9 right over there. So we look at the 1. Since the 1 is below 5, this stays at a 69%. So that means that this is the percent of bags that weigh less than 8.25 pounds. Okay, so let's look here. The amount of time a certain brand of light bulb lasts is normally distributed, very, very important, with a mean of 1,800 hours and a standard deviation of 65 hours. What percent light bulbs last more than 1950 hours? So again, they don't give us a specific interval, but we know that our lower is 1950, but we don't know how high we can go. We don't know how high these light bulbs can last. So, since we don't know how big this is going to be, we technically want to go to infinity. Now, with the thought that light bulbs can last forever, but we can't type infinity into our calculator. So we know our lower is 1950. When you have infinity, or when you want to represent a really, really, really big number, in your calculator, you just want to put in 999999999. However many you want, at least have 4 or 5 of them in there. This represents infinity. Okay? And our mean, like we said, is 1,800. Our standard deviation is 65. So let's type this in to our calculators. Normal CDF, 1950, upper again. We have to somehow show that this is going to infinity, at least in theory. If a light bulb lasts forever, that would be pretty impressive. Enter, enter, and this is what we get. So, we get 0.010508. Now, it wants a percentage, so we have to change this to a percent. So we move the decimal place over 1, 2 spaces, and it becomes 1.0508%. And then it says rounded to the nearest tenth. The tenths place is right over there. So we look at the 5. Since this is a 5, it becomes 1.1%. So that tells us that 1.1% of the light bulbs last more than 1,950 hours. Okay, let's look at one more. It says the scores of a recent test taken by 1,200 students had approximately normal distribution, super important, with a mean of 225. I'm just going to fill that in because we know we're going to need it. A standard deviation of 18. Determine the number of students who scored between, so there's our interval, 200 and 245. So our lower is 200, our upper is 245. Let's put it in normal CDF. Normal CDF, 200, 245, 225, and 18. Enter, enter, and we get 0.784 843. Okay, now this is going to give us the percent of students who scored between those two values, but it will not give us the number of students that scored between those two values. To find the number of students that scored between the values, we have to take our percent, so it's not in a percent yet because we can't do operations with percents, and we have to multiply it by the number of students who took the test. So here was our percent. We have to multiply it by 1,200 because 1,200 students took the test. So let's multiply it. So 1,200, sorry, I did it the wrong way. So 0.7843 times 1,200. And this is what we get. So when you multiply it, you get 941.16. So that means that 941.16 people scored between 200 and 245, right? Wrong. You cannot have 0.16 of a person. So when you're dealing with real life scenarios like people, you can't really round up. You can't have just automatically come up with a fraction of a person. So you always usually round down. So this will be 941 students. Okay, so I am going to show how to use Delta Math right after this, but in order to get credit for this class, complete this check for understanding question and upload it to the Google Classroom. Now I am going to show you how to use the calculator on Delta Math if you don't have it. So you're going to press this down arrow, go to Statistics Calculator, it'll bring you here. You're going to click on the main menu and you're going to go to Distribution. For submenu, you're going to press Normal CDF, type in all of your values, press Calculate, and your answer will show up. All right, guys, have a great day.